Have you always loved the clicking sound of the switches? And have you ever wondered what is happening behind them? Well, that's what today's video is gonna be about. Okay, now let's just learn about switch and its types. Switch is an electrical component which can make or breaks electrical circuit automatically or manually. Switches mainly works with the on and off mechanism. On means open position and off means closed position. Well, before getting into knowing more about switches, there are two important terms that define the switch. It is called a pole and a throw. Well, pole is the amount of circuits controlled by the switch, and it's indicated as single pole and double pole. So, a single pole controls only one electrical circuit, double pole controls two independent circuits in a single switch. Whereas throw is the number of throw indicates how many different output connections every switch pole can connect its output. So it is basically two types, single throw or double throw. So a single throw is a simple on off switch. So when the switch is on, the two terminals of the switch are connected and current flows between them. So when the switch is off, the terminals are not connected, so current does not flow between them. Whereas a double throw switch has a contact that can be connected to either of two other contacts. Whereas a triple throw has a contact which can be connected to one or three other contacts. So basically in movement of, as you can see from here, when you move on a single throttle or some controlling mechanism, you can change the amount of circuits that you control. That is known as the throw. And this is the basic electrical circuit or the electrical symbol of your switch. Okay, now here I have five different important types of switches, and we'll be looking onto each one of them. And then over here I have the surprise section, which I'll show you in the end of the video. Now let's just get into the first switch. So it is nothing but a push button switch, and this is the symbol for the push button. It is an example of an SPST NO switch. So as I already said, P means pole and T means throw. So it is a single pole, single throw. This NO means normally open switch. So this means that current cannot flow through the switch until the actuator has been pressed. So normally the switch is in a normal open position. So only when you press it, that time the current flows through it. So it is mainly used in calculators and many of the normal kitchen appliances we use. Now let's just take a look at the second switch. This is known as a DIP switch, and this is how it looks. Over here, as you can see, it is like integrating many switches in a single package. Well, a DIP switch is a manual electrical switch that is packaged with others in a group in a standard dual inline package. So DIP full form is dual inline. So basically it is generally used in electronic circuits mainly for representing the number of bits. So basically as you can see over here, for example, if we want to turn the third bit on or the fourth bit on, the switches are respective switches are being used to control it. So generally this is an 8-bit switch. You can see there are also many amount of bits switches you can use. So it is, as I already said, is a many switches in one package, and it is used in electronics generally, so general electronic experimental circuits basically, and then it was used in old cordless phone. Now let's just take a look at the next type of switch. This is a normal SPST switch, a single pole single throw switch. This is the symbol of it, and it's one of the most common switch that you see everywhere. So the two terminals either connected together or disconnected from each other. So when you press it, the one and the terminals get connected. When if you press 0, it won't get connected. So mainly used in light switches, and generally it is used in our day-to-day activities in mainly in our plug points. Now let's get into the fourth type of switch. This is the DPDT switch. I think from the name you can see it is double pole double throw switch. This is how it looks. It has 6 pins, 3 pins on one side and 3 pins on the other side. And I think this is well explained. Well, you can see there are 6 pins over here and 2 common terminals. So basically the B pins represent the normally closed conditions, and A pins normally represent the normally open conditions. So when you suppose move the throttle or the control mechanism up, the B gets connected to the A, and then this B gets connected to the A. This is how you can control many, no, two types, two switches. That's why the name is known as double throw. So it is actually equivalent to having two SPDT switches. So basically one side can be controlled as a single pole double throw, and the other side as another SPDT switch. So as already said, the position of the switch determines the number of ways in which each of the two contacts can be routed. Okay, now let's just take an example to understand more about DPDT. So this is in one of the circuit, having controlling a motor in in its clockwise and anti-clockwise direction. Let's see how a switch can being used to control the motor in both of its direction. Okay, now you can see here that the VS, and before getting into the connections, one thing to remind us, AB is connected internally and BC is connected internally, and then DE is connected internally and EF is connected internally. Okay, so basically when you move the switch up, that means AB gets connected. When you move the switch down, that means BC gets connected. So similarly for this side of the switch. So ABC act as one set of SPDT, and then the second DAF act as the second set of SPDT. Okay, so basically when we give a voltage, it goes through B, and then as I already told, suppose the switch is connected in such a way that AB is connected. So goes from B to A, and then A to D, and then goes from D to E, and then goes back to ground. So hope you can understand the flow of circuit. Um, so you can see it can control the motor in one direction. Let's assume it has to be clockwise direction. Now I move the switch from right side to the left side. That means that AB and DE becomes open, and BC and EF gets closed. So as you can see, the voltage pass through B and goes to C, and then passes through D, and then goes to A, and then from A goes to F, then F to E, and then to the ground. So hope you understood the flow. So it's very simple. You can see that in the first way, A to D was the direction. In the second time, it was actually D to A. So now the current flows in the opposite direction. So the motor moves in the anti-clockwise direction. So this is how, using a single switch, you can actually control the motor in two directions. There are also many other types of applications for the DPDT switch. And now let's look into the last type of switch that we have now. And this is actually an interesting type of switch. It is known as a DPDT, but it is an 8-pin switch. It is actually generally known as relays, and it comes under the part of electronic switches. So I'll explain why it is known as electronic switches or electrically controlled switches. It is actually not a manually operated switches. It is actually controlled by through electricity. Okay, now you can see it has 8 pins over here. This is how the module looks like. Well, the inner side, I hope you can see you have actually coils around there. From this symbol, circuit diagram, you can see how actually the switch looks inside it. Well, over here, the fifth and the sixth pin are connected to the seventh, and then fifth is connected to the seventh, and fourth is connected to the two, right? Well, this is known as the normally closed position. So, but in the second position, it will be like 7 and 6 gets connected, and 2 and 3 gets connected. This two contacts will go to from 5 to 6, and this from 4 to 3. Now let's just see how it happens. So you can see a battery is connected to the 1 and 8th pin, which is nothing but it's connected with a coil. So basically this coil provides magnetic field when a current is passing through it. So because of production of magnetic field, this the contacts actually gets clicked to the fifth to the sixth and fourth to the third. So this is how you can control two types of circuits, but one of the circuit is controlled such a way that only when a current is passed through it, otherwise it won't connect. So basically any circuit that is connected between 5 and 4 will be acting. Suppose you have something like a sensor input, it's been provided, and that time you have to change the circuit. That means if you provide current to it, it automatically moves the control to the third and the sixth pin. I'll explain more about it in the end of the video, so just stay tuned till that. Now let's get into the last section. to see some switches in action.
Okay, now let's just see some switches in action. Now these are the switches that we're gonna see today. This is the push button switch, the DIP switch, the relay, and this is your SPST, and over here I have my DPDT. Okay, we'll see the working one by one. So over here I've given connection over the positive and negative given from my 9 volt battery. Just the resistor is connected. It's the same for all the same connection for the all the switches that you have read in your previous section. So if I press the button, you can see LED is glowing, right? So that's the use of a push button. Now I have connected the second LED to the with the resistor to the one of the DIP switch. You remember that DIP has many bytes, right? So over here I have connected it to the first one. So if I switch it on, you can see that the LED is glowing. So if I switch it off, it goes off. So I can connect any number of LEDs at, for example, 1, 2, 3. Okay, now this is the normal SPST switch. So if I switch it on, you can see the LED glowing. Okay, now if we take a look at the relay, it is the same diagram that I show in the previous section. You have your coil over here and the common terminals, the normally closed position and the normally open position. Okay, so over here I've actually connected an LED in the normally closed position. It is actually glowing, but since the resistance is too high, it is actually dim. I hope you can see that. So the LED is glowing over here in your normally closed condition. So suppose if I give over here, I'm gonna pass current from the white wire. This is the negative terminal of your battery. I'm gonna connect it to the the inductor that is present inside it. So if I connect it to the inductor, so as I told, the normally closed position gets connected to the normally open position. Okay, I hope you can hear the sound. Yeah, there'll be some sound, the clicking sound that takes place when you actually connect your inductor to the if we pass current to the inductor part. Now let's just see the working of the DPDT switch. You can see the motor is running at one direction, right? Now let's just see the change in direction of the spinning of the wheel. So yeah, so now it's actually going in clockwise direction. If I touch it out, you can see it is going in clockwise direction. If I change the polarity of the switch, now we can see it's actually going in the anti-clockwise direction. So the connection is same as shown in the previous section. So this is how with the same switch you can actually connect. Use the polarity by changing the polarity of the switches. You can change the direction of the motor.
That's all for the video guys, thanks for watching.